So we're going to be talking about parallel and perpendicular lines, and when we consider the equation y equals 2x plus 5, we're going to discuss whether or not equations given here are either parallel or not parallel. So the equations that are parallel, examples of them are like this: y equals 2x minus 7, y equals 2x plus 4, and y equals 2x plus 8. Equations that are not parallel include y equals 3x minus 8, y equals negative 2x plus 5, or y equals negative 1/2 x plus 4. Now we should be picking up on some similarities in terms of what do all of these share, all of these four equations share. Well, you'll notice that the slope for all four of these equations are the same. And you'll notice on this side that the equations for slope are not the same. So as we go through and determine which lines are parallel or not parallel, we'll be able to look at the slope and determine that. So when we look at this here, y equals 2x plus 5, our same example, and we're going to determine whether these lines are parallel or not. So the first one we have is y equals 2x plus 3. Is it parallel? Yes, because the slope is the same, right? The slope indicated right here is the exact same as this line, therefore it is a parallel line. The next one, y equals negative 2x minus 7, that would be not parallel. So it would not be parallel simply because the slope is different. Even though the m value is the same, this is negative, whereas this is a positive slope. And the third one we have, y equals 2x minus 7. Is it parallel to our original equation here? Well, yes it is, because the slope or the m value is the same. So as we go ahead and graph these, so we're going to graph this line in orange, y equals 2x plus 5, right? And quickly label it. I know my y-intercept is 5, and this slope of 2 is technically 2 over 1. So when I go ahead and plot that line, it's going to look something like this. I have my plus 5 starting area, and I go up 2 units and over 1 unit. So I have a line that looks like this. Right about there. So we can see how, starting at our y-intercept of 5, my slope is up 2 units over 1 unit, up 2 units over 1 unit. And I can do that all the way down as well, so long as I'm following the slope of 2 over 1. In our blue line, we have y equals 2x plus 3. Well, my y-intercept's different. It's 3. And when I graph that, I'm starting at 3, and the slope I have is still 2 over 1. So up 2 over 1, up 2 over 1. And now I have a line that looks like this. Right? Starting at our y-intercept of 3, up 2 units over 1 unit, up 2 units over 1 unit. So the blue and the orange line are parallel to each other. Then our third one we have, y equals 2x minus 7. Well, my minus 7 is my y-intercept, so I stated it down here, and the slope is the same. So up 2 over 1, and I could keep going up 2 over 1 all the way through. That line didn't graph very well. There, that's a little bit better. Either way, we know that all three of these lines have the same slope. Therefore, when we plot them on the graph, we can see that they run parallel to each other. So in our own words, how can we write an equation of parallel line? If the slope is the same, if the slope is the same, it is parallel. Now we're going to consider this new equation, y equals 3 over 4x plus 4. So these equations are perpendicular, and these are not perpendicular. So when let's look at the perpendicular here. I have a slope of negative 4 over 3 plus 4, y equals negative 4 over 3 plus 5, y equals negative 4 over 3 minus 2. We're noticing something about the slopes. The slope of the given line is 3 over 4. The slope of a perpendicular line is negative 4 over 3. We call that the negative reciprocal. So when a slope of one line is given and another line is given and the slope is a negative reciprocal, we know that these lines are perpendicular. And you'll notice that on the right side over here, you'll see that these slopes, while they're not the same as 3 over 4, they are not perpendicular because they are not negative reciprocals. So as we keep going through, are these lines perpendicular to y equals 3 over 4x plus 4? Well, let's see here. Y equals negative 3 over 4x minus 2? No, because it's not a negative reciprocal. What about this line? Y equals negative 4 over 3x minus 1? Yes, it is, because the slope is the negative reciprocal. And when we go ahead and graph these lines, the original line graphed, y equals 3 over 4x plus 4, is right here in pink. Right? I know my y-intercept is 4. My slope is rise over 1 of up 3, 1, 2, 3 over 4, 1, 2, 3, 4, and those are my plots. And my other two lines, y equals negative 4 over 3x plus 5. I start at 5. I go negative 4 over 3, negative 4 over 3 for my plots. And then my other line here in gray is the same slope, negative 4 over 3, and the y-intercept of negative 2, so it starts here. So both the yellow and the gray line are perpendicular, and you can see here I've indicated that it is a 90-degree angle between these lines. So this is the visual representation of what a perpendicular line looks like when we graph it. So the big takeaway, or sorry, before I get to that, in our own words, how can you write the equation for a perpendicular line? Well, a line with a slope that is the negative reciprocal of another is perpendicular. So the big takeaway would be, if you're looking for a line that is parallel, the slope is the same. And if you're looking for a line that is perpendicular, it needs to have the negative reciprocal of whatever line that's been given to you.